All right, so we're going to dive into designing a network, and we have John Smith, who is known as Chief Technology Officer, and Scott McIntyre from Nokia, and they're going to give a presentation on some things to consider. You know, if you see a broadband network deployment in your future, this will be a great base level knowledge for that. And like I said, I think I'm going to pick up some things as well, because there's just a lot to know when it comes to networks. So with that, I will hand it on over to you two.
Okay, thank you, Claire. I'm going to share my screen and start the presentation, and let me know if you're seeing the full screen there, or if you're seeing the presenter screen. You got the full screen? It
looks right. Yep.
Okay, great. Yeah, I have the multiple monitor issue like Angela all the time as well, so I can relate to that. And thanks to Angela and Jeff and Chris. You know, the presentation so far have been great. There are some things in this presentation that may build a little bit on some of the things that were covered earlier, but hopefully everyone will get something out of it. It is kind of like you know, we're kind of letting the geeks out here now, right? So it'll get a little bit more technical, but as Claire said, we're going to try and keep it as high level as we possibly can. And I'm happy to have Scott McIntyre from Nokia here with me. As Claire mentioned, he is I'm gonna handle the first portion of the presentation, which we centered around fiber, and then he'll do the second part, which is really around some of the wireless benefits. So with that, we'll start with a couple warm-up slides here. So how fast is fast? Okay. This, you know, I always, you know, people never really understand, you know, when you give speeds, what it means in terms of real world usage. And so I just like to, you know, I threw this together just a few minutes ago, just to kind of give an example of, like, if you were to download a HD movie on 5 megabits, and I started at 5, you know, a lot of people don't even have that if they're in very rural areas. And then all the way up to 25 gigabits per second, which is what you can achieve now over the GPON network, or the gigabit, 25 gig PON networks. So you can see the difference in download times for these different types of content. And obviously, what you know, where we're shooting for now is around 150 megabits is the new target. And you can see that's great, but we'd love to see it keep pushing up and up this scale till we can get 10 gigabit to the home. It seems crazy to have 10 gigabits to the home. That used to be reserved just for the largest carriers for middle mile transport, which Chris talked a lot about earlier. But now there's actually homes with 10 gig connections to them. So we'd like to see that more broadly deployed, and fiber allows us to do that. So let's talk a little bit about how those speeds are delivered. So fiber, what is fiber? Okay, it's just glass, and it carries data via pulses of light through it. And if anyone's curious, it travels at about 124,188 miles per second. And for the real geeks out there, you'll notice that that's a little slower than light travels through a vacuum, which is 186,000 miles per second. But it's still fast enough to go around the Earth about 5 times in 1 second. So you know, it's not surprising you can get an email from another country instantly now it's going through a lot of other stuff, but the rate at which these pulses travel through fiber and the distances they can cover is just astonishing. So what are some of the current, you know, right now, some of the highest speeds that are available over fiber network to a residential location is 25 gigabits per second, which was in that chart I just showed you, and that's utilizing a PON network, which I'll talk more about in a few minutes, and what that technology is. However, you know, we talk about future proof, and Chris mentioned that they haven't found a limit for the capacity of fiber yet in data throughput. The current fiber transmission speed record's about well, it is 319 terabits per second, and that just happened this year. So in terms of gigabits, right, we said the fastest speed right now you can get is 25 gigabits, which is fast, right? Even 1 gig. This is 319,000 gigabits per second. And that's over a single strand of fiber. So this is astonishing, the speeds that are. Now, again, this is done in in a lab environment. Using a lot of special equipment, but it shows you what the capabilities are in the future and where we could go. It was the record just one year ago was 178 terabits. So it went from 178 to 319 in 1 year. Again, it's just astonishing. There's now Chris again talked a little bit about wireless, and there are some different wireless technologies, and Scott will talk more about this towards the end of the presentation. But there's Wi-Fi, which we're all familiar with. It's what we use in our homes, and it's good for community hotspots, business hotspots like Starbucks and other locations. One of the newer wireless technologies is the Citizens Broadband Radio Service, which is commonly referred to as CBRS. So if you hear CBRS in your conversations, that this is what they're talking about. And it's a lightly licensed technology, meaning that it uses spectrum that's not licensed, but there is some coordination between the people that use it. And you have to coordinate with other service providers utilizing that spectrum. So it allows for greater coverage. It's more reliable. You don't get the same interference that you see with a completely unlicensed deployment, like a Wi-Fi deployment. And then, of course, the ultimate would be a licensed wireless, but I'll let Scott talk about that in his challenges section of getting license for wireless. Like the tribes have the ability to get 2.5 gigahertz licensed wireless, which is just nirvana of spectrum, but unfortunately that's not available to anyone outside of tribal areas. So it is nice, but there are a lot of challenges with it. And those are the two we're going to focus on because they're really the options that we have as utilities, municipalities, and others. There's, of course, out there's other competing technologies like DSL, which just uses your phone lines. It's typically a lot lower speed, although they're pushing the limits of that as well. Cable, it's getting better and better, but they have a lot of capacity on the coaxial cables, and most of their networks are hybrid fiber and coax. And they're getting more and more bandwidth out of those coaxial cables so that, they can offer 1 gigabit or more now to the home. And with the newer technologies, they're getting up around 10 gigabits over those coaxial cables. So continuing to see advancements there. Again, not something we can utilize typically, but it is a competitor of most of the deployments. And then Chris talked about satellite. In the past, we had Hughes satellite and others. It was really slow, really laggy, very expensive, but that's changing. As he mentioned, Starlink, which is operated by SpaceX, which is owned by Elon Musk, is expanding at a pretty fast rate. It has much lower latency. It's in low Earth orbit. And is a really good solution for very, very rural areas that have no other options. So we'll start hearing more and more about Starlink as they get more satellites up in orbit. So, like I said, we're going to split this into two. Is fiber always the answer? It's not. And one thing to consider is when building out these networks, I know Jeff said they're set on fiber everywhere, but there may be situations where you run into rock. There's no overhead poles to run your fiber on, and it's just almost impossible to get to a small group of people. That's when wireless can come in handy. Fiber, of course, it gives you the best future-proof capacity. It's a lower operating expense because most of the infrastructure out in the field is passive, as Chris talked about passive and active. Passive meaning there's no powered equipment, whereas with wireless, you have these powered access points all over the place that you have to maintain. So it has a lower OpEx, and it also gives you a lot of flexibility. It's not just for residential. You can lease dark fiber to large corporations if they want it. You can use it for your internal needs if you need to. It gives you a lot of options as far as utilizing that fiber. Of course, wireless, it's fast. You can get it out there. It's cheaper. You can get peak rates pretty high depending on how many users are using it. And it can complement or even compete with some of the fixed systems. All right, so let's focus on fiber here for a few minutes. So why should fiber be your first choice? And that's what we believe. Fiber should always be the first choice. And again, Chris, some of this will be repetitive from Chris's presentation, but it never hurts to hear it again. Consumers want ultra broadband, right? They're, wireless may serve their current needs, but there's no guarantee that that wireless is going to serve their future needs. And there's just a list of kind of services and things that people utilize for broadband today, but who knows what's going to be happening tomorrow or 10 years from now when that fiber infrastructure will still be in place. And speed is a key selling point. Cost is also a big component of it, but speed is definitely there. And we're seeing with all the competitors out there, I mentioned cable providers are hitting gigabit speeds. The telcos are building out their fiber network. So there is a lot of competition with, a lot of high speed competition in the more urban areas, not so much in the rural areas. And you're seeing more and more players, as we know in Washington State, especially, we've seen a lot of PUDs, municipalities getting into the telecommunications business and being very successful. There's also some non-PUD utilities that are doing telecom as well. So a lot of people doing it, and again, because speed and the future is on, what the speeds need to be in the future are unknown, fiber is always going to be our recommendation when possible. So if you decided on fiber, what are your options? And here's where it's going to get a little bit more technical. When you think about how you're going to design and build out this fiber network. Again, Chris mentioned PON, a passive optical network. And the reason PON is considered, they call it passive, is they have this optical splitter out here that you have a single fiber coming into. And this OLT, which is basically the aggregation point of all the customers, that's going to be in your main data center or maybe a substation if you're a utility. It could be, but it's going to be where you're aggregating a large group of customers. One PON OLT, one shelf, can support up to 8,192 customers out of that single shelf, and it does it with only using 256 fibers. So how does it do that? And the way PON works is this splitter. If you have a single fiber coming out, this splitter is typically, you can do different split ratios, but the most common is a 32-way split. So you'll have a single fiber going into a neighborhood, and that neighborhood may have 20, 30 customer, residences in the neighborhood. So you would put a cabinet, a passive cabinet, no need for powering it or anything, just a cabinet to hold the splitter outside of that neighborhood. And then you'd run your higher capacity, a single fiber to each of the homes in the neighborhood. And if you have more densely populated neighborhoods, you run 2 or 3 fibers and then you multiply that times 32, and that's how many you can serve out of that cabinet. So what it does is, instead of I'll contrast that with this point-to-point Ethernet. Depending on whether you're using single fiber or dual fiber Ethernet, you can use bidirectional, and I'll use one fiber just to make it comparable. But if you wanted to serve, in this situation, you wanted to serve a neighborhood with 32 customers, here you use one fiber to the neighborhood and run your fiber around there. Here you would have to run 32 fibers to the neighborhood, all the way to the neighborhood from your hub. And active Ethernet sort of is a hybrid of that. It runs a lot like the PON. It runs, whoops, sorry. My mouse is very sensitive. Instead of running multiple fibers all the way out to the neighborhood, you can put a switch in the neighborhood just like you put the splitter close to the neighborhood. The only difference is this is an active cabinet, because this switch has to be powered, and depending on whether it's temperature hardened, you may have to put in AC, or at least heat exchange fans, and potential battery backup and everything if you want to keep those services up during an outage. Whereas with the PON, like I mentioned, this is completely passive, so there's no batteries, there's no power needed, nothing. So that's the advantage. The fiber counts are roughly the same between this and this, but the density you get out of the OLT cabinet is much greater. And you can see in the early days, GPON, which is it's currently available and by far the cheapest PON technology, excuse me, today, is 2.5 gig down and 1.2 up, and that's for however many people you put on a splitter. So the one fiber feeding this splitter has 2.5 gigs to share among those 32 customers on the download side, and Chris talked about download versus upload, and 1.2 gig going back up. Now XGS PON, which is also currently available, a little bit more expensive, but the costs have been coming down, is 10 gig symmetrical. So it's got 10 gigabits going down, 10 gigabits up for each of the for the 32, or if you've got 20 customers, however many off. But the port that it's plugging into here is a 10 gig port. And that's a lot like this. Generally, the uplink from this is, it can be gigabit, it can be 10 gig, it could even be 100 gig if you wanted to, but you're still aggregating customers at this point. And that's what you see here. So that's XGS PON. And then there's 25 gig PON. This is what I base that chart on. This is very new technology, a little more expensive now, probably not going to be what you would deploy today, but it certainly is some people are deploying, but that gives you 25 gig symmetrical on that single fiber shared among those 32 customers. And I'll talk about this a little more in a minute, but the nice thing about this OLT, which is optical line terminator, this shelf, you can put a GPON card in this slot, you can put an XGS PON card in this slot, and you can put a 25 gig PON card in this slot. And they can all be combined and sent over one fiber. And then you would just put the different types of customer equipment on the home, and they would be, and you could mix and match the types of services you offer to those end users, because they're using different lightways, which again, I'll talk about that in just a minute in a little more detail. So, what we typically recommend when we're doing consulting work or doing design work for municipalities or other entities is a PON network. There are some successful Ethernet networks. There are some successful active Ethernet networks out there. And a lot of times it's a mix of these. Some people may use the PON solution for their residential, and they may use an active Ethernet or a point-to-point Ethernet for their business solution. And then there's no reason you can't mix and match these different types of deployments. However, PON really can handle most of the services you want to deliver. There's nothing wrong with using these other ones as well. You just have to, the big part of the one important thing is going in, you need to know kind of what you're going to use, which of these technologies you're going to be using, because your fiber counts, the locations of your cabinets, the requirements for your cabinets, the power, the batteries, all are going to help determine what the outside plant looks like. When I say outside plant, I mean the fiber that's being hung on the poles, how big those fiber cables need to be, how many fibers need to be in that cable to serve a neighborhood and the neighborhood down the road. So you can't build the fiber and then come back and decide which of these you're going to deploy, or you're going to be in trouble, especially if the person putting it in is thinking this and you decide to do this. You're not going to have near enough fiber and you're going to have to go overbuild yourself. So it's important to plan for the outside plant, even though it's the first thing that goes in. You need to know what you're going to be lighting it with when you're finished, in order to make sure that that is designed in the most efficient way. So I will jump to the next slide. And so why is it important that your outside plant is designed in the right way? So that's what we'll talk about on this slide. This is that access node OLT I mentioned. This is the one that can serve just a single shelf here, can serve the 8,192 customers. And this it doesn't have the splitters and everything, but it's just just show the different components of the network. You have your ONT, optical network termination, on the side of the home or business. And then you have your fiber plant. That's the fiber on the poles or in the ground in conduit that you're trenching or boring to get in the ground. And if you look at this chart right here, this is why it's so important to know what you're going to end up with and how you're going to be lighting that network. Because if you look at the distribution of cost for fiber to the home, you can see in this chart, this biggest chunk of your costs are in the outside plant. And that's in the fiber that's running through the neighborhoods, all of that. So it needs to be done right, it needs to be designed right. And again, it needs to know how it's going to be lit. And then the second is the home installation connection. That's basically putting the ONT on the side of the house and getting the drop cable from the pole to the house, or if you're going underground through a conduit. And then you have home equipment. Oh, sorry, this is the drop cable. I'm sorry, this is the equipment. This is actually the cost of the equipment that you're putting on the side of the house. This is just the drop. And then this little tiny sliver right here is the actual cost of your network electronics, everything you're buying to light that fiber. So a lot of people don't think about that when they're doing this. You're thinking that, the network electronics are going to be expensive. It's going to be a big cost associated with this. They're not. Compared to the outside plant and the drop to the home, it's a small fraction of your overall cost. So that
I have a question for you.
Okay.
This was a really good point that you really have to think this through and kind of know, you need to know what Z is at A when you start thinking about how you're going to design your network. What does this look like if the plan is for dark, to not put electronics on it? Do you still have to think about, well, I'll stop there.
Well, if you're just going to be doing a dark fiber, it's going to look a lot like this point-to-point Ethernet solution. You wouldn't have splitters, and you're not going to put in Ethernet switches because this lights the fiber, so this will be gone. And you want to have the greatest amount of capacity along all your main routes as you can possibly get, to be as flexible, because you don't know what kind of services are going to be offered. Whoever's leasing that fiber from you is going to be offering. So generally speaking, it doesn't, the cost between, let's say, 144 count fiber or 288 count fiber, it isn't double. It's just, it may be 10 or 20% more, whereas the cost of hanging on the pole or run it through the conduit is the same. So it always, if you're going to do dark fiber, it's always better to overbuild, get the max fiber count you can get for what you can afford, because you don't know what it's going to be used for or how it's going to be utilized. A lot of utilities put dark fiber in to connect their substations together, and then later on decided to get into telecom, and even using a PON network, they put in 48 count fibers because it's what they thought they needed for their own internal use. But that turned out to not suffice for a residential fiber build out. So, and they end up overbuilding themselves, putting fiber on top of fiber, that, having two cables running down the road instead of one. So planning for that, it's a little more difficult, Claire, because you don't know how they're going to use it, but the higher count, the better. Here, we're trying to minimize the fiber count. And with dark fiber, you kind of want to maximize that to get maximum revenue out of it.
Right, and it sounds like have the most flexibility down the road because you
right.
don't know. Okay, and then a couple more questions have come in. Is there a greater, I don't know what this means, MTBF for a GPON splitter compared to an active fiber such as an Ethernet switch?
Well, it depends. It's mean time before failure, or what did you say, MTBF?
Is there a greater MTBF for GPONs, for a GPON splitter compared to an active fiber Ethernet switch?
It's a much longer mean time before failure on a splitter because, again, it's a passive device. Their Chelan PUD, for instance, they have splitters that they put in year 2000 that are still there and working. Now, granted, there's probably some Ethernet switches that were put in the year 2000 that are still working too. But because an Ethernet switch heats up when it gets hot out, during it, it's an electronic device with a lot of electronic components. There's many, many more components of that Ethernet switch that can fail than a optical splitter, which is essentially just a piece of it's a prism splitting light waves that has no moving parts, nothing, no power. So the mean time before failure would be much longer with an optical. So I don't have the exact numbers. Scott, I don't know if you know the exact numbers, but
I would just add to that is the fact that optical splitter and that Ethernet switch are sitting in a cabinet out in a neighborhood, and that optical splitter, there's no power going to that cabinet at all. And let's say it's supporting 256 homes from that cabinet. And let's say you compare that to an active Ethernet network where that Ethernet switch and that cabinet is also supporting 256 homes. First of all, it's going to be a much larger cabinet to support the Ethernet switch. You have to bring power to it. You're going to run some sort of battery backup to it. So you're going to have a bank of batteries that are going to need to be maintained. The DC rectifier and the battery plant and the Ethernet are going to generate heat. And so you're typically in most of Washington, you're going to have an air conditioning unit on there. All of those things actually cost money to run, and all of those things also are going to have a maintenance life associated with them that can result in eventually will result in a truck roll to either replace them or maintain them.
Thanks, Scott. Any other questions or go on?
This has less to do with the technology. Do you know why no one leases dark fiber, but we don't usually lease it out? Is that a networking issue, an engineering issue?
We don't. Well, we lease. I'm not sure that question. I'm trying to understand the question better, but we have limited capacity. We have limited fiber capacity. We lit most of our network, and we lease fiber from other people on a lot of our routes. Bonneville Power Administration, for instance, we lease a lot of fiber from them, and we have no excess capacity along those routes. We lease what we need from them, and that's it. And that's all they do. BPA only leases dark fiber. They're a complete dark fiber network. And we have, where we do have fiber capacity, which are routes that we built under the BTOP program back in 2009 to 2012, we have leased some of that fiber to other carriers, and in a couple where we had excess capacity. But again, because we utilize a lot of that ourselves, we don't have a lot of excess capacity for leasing dark fiber.
Okay. Yeah, that makes sense. And I know I've heard folks say in the past that, knowing that we believe so much in open access, like we don't want to, if we can lease from someone else in an open access fashion, we'll do it. So that makes sense for what you're saying.
Right. Yeah. And if we have, if we might have a high capacity between 2 points, but then it gets bottlenecked there. So, and nobody wants to go between those 2 points. They're trying to go from A to Z, and we can only get them from A to B. So we're not in a good position to lease dark fiber, except on certain routes, and they're usually the more rural routes that we built under VTOP. Other places we don't even have any capacity at all to lease.
Perfect. That answers the question. Thank you so much.
Okay, I think I covered this slide, really, again, focusing on the cost and how little the electronics cost is compared to the rest of the build. And so how do why is fiber a good solution versus coax? Okay, let's use coax again in this example. With coax, you're running essentially, well, again, here I go, I'm going to get technical. I don't want to get too technical, but they can I don't want to say modulating. They have a limited capacity on that coax, whereas with fiber, you can send different colors of light. They call them wavelengths, but essentially it's just a different color of light. And you can layer those on top of each other. So when I was telling you back on this slide that you could put a GPON card in here, an XGS PON card in here, and a 25 gig PON card in here, and put them on the same fiber feeding the neighborhood, this is how it's done. It's done by inserting multiple wavelengths, right? Your GPON, if you're doing GPON today, it's just it uses 3 wavelengths, but represented as 1 here. And then later you can add XGS PON, then you just use a different way. And these can exist simultaneously on the same fiber because they don't interfere with each other because they're totally different wavelengths. And then later, if you want to add XGS PON or any other wavelength services, you can keep layering those into that same fiber. So that gives you a tremendous amount of flexibility, and it leaves that this big investment that you're making right here. You want to maximize the value out of that in every way you possibly can. And by layering in wavelengths into single fibers and getting as many services out to customers as you possibly can is the best way to protect that investment. And fiber allows you to do that. So just some of the key things, and again, Chris covered a lot of this, so I won't spend too much time on this slide. There's where do you want to build? How much is it going to cost? What's your deployment strategy? I put cherry picking areas. When COOS is one of the sponsors of the conference, and they do a good job of allowing you to look at different areas and find out where the demand is. And then build in the higher demand areas first so you can generate early revenue to help subsidize the build outs in the areas that may be less dense or that generate less revenue. And it's just a fact of life. Everybody would like to say, I'm going to start in the most rural parts of the community first, but those are the ones that are going to cost the most and generate the least amount of revenue. So depending on now one way you get around that is, I mentioned one is when I say revenues, I'm talking about revenues from customers. The other option is to get a grant. We've heard a lot about the grant. Lewis has submitted a grant that, they talked a lot about that. And that does help because a lot of times you can only spend that money in the very rural areas. So that allows you to build out in those very rural areas, not being as concerned with your return on investment because grant funding has funded all of that. You don't have to recover that capital cost. But if you're paying for the capital yourself and you need to recover that, what is your strategy for doing that as effectively as you possibly can? And that's something that we've done a lot of work in, and certainly have helped a lot of different communities figure out how to do that to maximize their investments and again, generate that revenue so they can fund the more rural builds. And this one, again, it's a little bit repetitive from Chris, but don't forget about your businesses. We always talk about fiber to the home. But a lot of revenue comes from businesses. Their business spend can be 5 times what residential customers spend, and this is and it may not typically a mom and pop shop that may be just buying internet for a point of sale device, but if you've got larger businesses that need VLAN connectivity between offices or something, those are higher dollar items that you can sell over that fiber network, over the same infrastructure that you put in for your residential. So it's important to carve out a set of services that target the businesses as well as the residential customers. And you again, choosing the business model, Chris told you we really support the open access model, the wholesale model. And as far as the network design goes, I tried to simplify this as much as possible. Everybody's using the same equipment from this point out, towards the customer. This would be whoever owns the infrastructure, the municipality, PUD, utility, whoever. And the fiber out to the homes. And then you would connect on the backside of this to different service providers. And then you could send one customer to this service provider, you could send this customer to this service provider. And then on top of that, you might have some application service providers that want to come in and sell services over the top of your fiber network. So you might have somebody with e-health services or security services. They want to come in and offer to your customers, and you just get a piece of their revenue. And look for revenue sharing opportunities. So it, kind of creating that business model that works best for you and that will help support the network and drive as much revenue as you can out of it is another important component. And getting multiple service providers competing is a good way also to keep prices low. Some rural areas, it can be hard to get more than one. And what we've seen in most of the open access residential deployments is there's usually 1 or 2 really strong service providers, and then maybe 4 or 5 more that just do limited play and services. So with that, I'm going to kick it over to Scott and let him, that's all about fiber from a 1,000-foot view. And now I'll turn it over to Scott, and he's going to do a 1,000-foot view of wireless in a little more detail than what Chris talked about earlier. So Scott.
Thanks, John. You can go ahead and switch over. There we go. About how much time do we have? I know we've got probably we want to leave time at the end for questions. But what do you think, Claire? How much?
Well, we have 20 minutes left. If you can do 10 minutes, I think that would be really great.
All right, 10 minutes it is. My clock's ticking. So, as John mentioned, I think anybody's first choice would be fiber, but it's not always feasible to do that. And wireless technology, we've used it a long time. And if you look at what the if you're in a public safety environment or the DOT, the state patrol, any county, any city, they're using wireless technology to talk to their land mobile radio, to move data. The land mobile radio units are talking to microwave dishes on the hill, those big drum looking things on a tower up on a high peak. And we've been doing that for a long time, 50 plus years of that technology. And over the year, it's gotten better and better and better. And we're able to move more and more data. And so a lot of that broadband backhaul that John mentioned, if you don't have the ability to put a piece of fiber across a right of way, maybe it's a train track or a waterway or something like that, you can utilize licensed wireless point-to-point type equipment that can provide huge amounts of bandwidth and enable you to make that crossing across a right of way that you might you may have a difficult time getting across. So the wireless technologies, even in the backhaul, like I just mentioned, are very complementary. And so now we're going to talk about fixed wireless access, which is the connecting to a device, and that device could be at a computer.
Scott, can I interrupt you real
Yeah.
quick? Sorry, I just wanted to add that another thing we do with microwave is it can also, if you want to provide redundancy to a location and you cost a lot to build out to it and you don't have the money to build another route to it, you can use maybe it might be a lower bandwidth connection, but if you lose, you get a fiber cut, you can still have an alternative route over that point-to-point microwave, so it can be utilized for redundant connectivity as well.
Yeah, and there was actually a question that came up earlier too about millimeter wave. The very high frequency, you can get a lot of bandwidth on these things. We're now pushing 10 gigabits over a single channel, short distances. We're talking, half a mile, maybe a mile. But that's, you think about a half a mile, that's still pretty far. And you can get from a building to a building, you can get across a river, you can get across a railroad track. You can do a lot of things with a giant pipe in a short distance that are very reliable. I'll just pick on fiber for a second, but there's an old saying that, any idiot with a backhoe can cut a fiber, but it takes an act of God to fade a microwave path. And that's kind of been a long saying, but again, they're very complementary to one another in the sense that they can be used in the backhaul or in the front haul, like we're about to talk about, with these the endless use cases. And what we're seeing a lot more now, and before I talk about the use cases, one of the things I will point out is, we haven't seen a lot of utilities or municipalities or other state and local government agencies deploying their own wireless broadband network. And why is that? Well, if there is a piece of wireless spectrum that you can license so that nobody else can use it, so it's going to be your own and private, and nobody's going to be stepping on it like your neighbor with Wi-Fi, and your signals are running into each other and causing problems. If there is a piece of spectrum that is big enough to be useful for moving lots of data, that is a tremendously valuable piece of spectrum. And the chances are the carriers have purchased that so that they can sell services. And so when it comes to a utility, a muni, a state and local government agency who would have lots of uses for these technologies, they're competing against the carriers that have very deep pockets that essentially buy up all that available spectrum from the FCC for their own commercial uses. So hopefully, and this is something we're actually starting to see more of, I'll talk about that in a moment, but hopefully what we'll see is more spectrum becoming available for municipalities, utilities, government agencies to deploy these private wireless networks for not only for residential broadband, but also for other applications and these use cases. I'll talk a couple about them. So a utelco, a utility that is also acting as a telco, or a municipality that wants to, or a county that wants to offer broadband, whether they're wholesale or retail, they would connect those to their residents. But the other thing that they would do for it, say, for example, a utility, that communication infrastructure can be used for the utility operations, right? So we're talking about things that utilities have been doing for many, many years, such as SCADA, distribution automation, distributed generation and microgrids, small communities with their own power generation, advanced metering initiatives for reading meters or controlling meters, the land mobile radio that they use to communicate to the trucks in the field, that two-way data to the trucks in the field to push information. And one of the big ones lately is fire prevention. So you'll remember the fires in Northern California that bankrupted Pacific Gas and Electric and caused lives lost, billions of dollars in losses. We can now use wireless technology to high-speed wireless technology to be able to detect things like a falling conductor and detect when that line breaks and be able to de-energize it before it hits the ground and potentially stopping that fire from happening in the first place. But to do that, it requires extremely high-speed communications that have to be reliable. And so again, we need to see more and more of this spectrum become available for utilities and municipalities. As far as municipalities, everybody's probably heard of smart cities. These are emergency, these are kiosks in the community that feed information to bus stops, people walking by. You can get emergency notifications, smart light poles that'll save the city money, smart parking, traffic management, EV charging stations, and again, land mobile radio. All of these different technologies can be consolidated onto these wireless networks for reduced operational expenses and reduced complexity and more reliability. But one of the key things, going back to residential broadband, one of the things that's so attractive about fixed wireless access is the speed in which it can be deployed. Because you can take a access point, you can get it up on a pole. Maybe you have fiber to that pole. Maybe it's a microwave backhaul that you want to connect to that pole. And again, maybe I can go from the top of that pole to my, my point of presence, my, my internet pop, if you will. And I could deploy that microwave hop to the pole, and then from the pole, that access point that reaches out, and it touches many homes in the neighborhood. So you can imagine how much quicker that is than trenching fiber and connecting an actual fiber line to the different homes. So it's a very complementary technology. It can allow you to really be the tip of the spear, get into the neighborhood, deploy the wireless, get people connected while you come in behind and build that fiber network over time. So again, very complementary. I'm going to go ahead and move to the next slide, John. So this slide actually kind of what you're seeing is an aerial view of the community, and imagine there's a pole in the middle of it, and on that pole there's a base station, and it's radiating out. And we know a lot about the topologies where we're deploying these things, and so we can make predictions about how good of a signal that we're going to get. Typically, the frequency that you're going to use these days for fixed wireless access is a band known as CBRS, and that's in the 3.65 gigahertz. It is a fairly high frequency, which means it doesn't go very far. The good news is it's got a big, it's capable of a lot of bandwidth, and so it can be used in both a unlicensed mechanism, so anybody can deploy this. So we're seeing this in wireless ISPs throughout the country. Or again, if you're a utility or municipality and you want to deploy this, you could do that without a license, and you could put up these CBRS base stations, and there's a whole ecosystem of devices that you can use to connect to. And even in the PON portfolio that John was mentioning, that device that goes at the house, that's an ONT. And that is typically connected by fiber. Well, manufacturers also have ONTs that instead of a fiber interface, it has a wireless interface. So it's a CBRS interface. So the good news about that is I could be deploying fiber-based assets and wireless-based assets, and they all are talking to the same network at the core. They're being managed by a single network management platform. And so there's a lot of, we're seeing a lot of, I guess, symmetry or similarity it's operating together very harmoniously, I guess. But one of the things that you do have to be very aware of is that is this list of dependencies that we showed here, such as spectrum. I mentioned CBRS. As more frequencies become available, they can be deployed for these fixed wireless access, indoor versus outdoor. Again, if your antenna is facing your base station and there's a clear line of sight, you're going to have a better signal. That's just if it's inside behind a metal panel, a brick wall in the basement, it's going to be troublesome. Just imagine your cell phone when you go into an elevator, into a parking garage. Same type of operation. We see improvements, however. We see improvements in performance through technology, things like the way that we build the antennas and the way that our base stations and our antennas and our CPE, as those improvements come along through technology, we're able to have a higher quality signal. We're able to not have to have as tight as stringent installation requirements, and doesn't have to be as high, doesn't have to. So all of these, as technology marches forward, we're able to loosen up those restrictions on how we can mount and deploy that wireless technology. But at the end of the day, there's a lot of voodoo and black magic that goes into wireless networks, and that's again why fiber is so great, because that light comes down the fiber, like John says, and it's a very well-known. You're dealing with a lot of well-known issues, if you will. So John, go ahead and go to the next slide.
Yeah, I think I'll skip the next one, Scott.
Yeah, go ahead and skip the next one and just go to that final one. And this is a good one, because really, if you look at the boxes on the right side, it's really about, what we've got is a toolbox. We've got a toolbox of technology that you can deploy that will enable broadband for your residential subscribers, as well as broadband for your operation. So again, if you're a utility or a municipality, there's a lot that you can do with those wireless technologies, with those fiber-based technologies, to increase your efficiencies, to make your systems more reliable, and reduce operational expenses. And the network that you see there, those technologies on the right side, the fixed wireless, the PON, the active Ethernet, they're all tools in that toolkit. And John, I'll let you go ahead and wrap up anything else that you want to talk about there.
Okay. Yeah. Thanks, Scott, for taking on that component for me. Yeah. And I'll just do the summary and wrap that up. Basically, I'm not going to read all these, but fiber is our choice. It's really kind of our first choice if it can be deployed affordably or by utilizing grant funding. That would be our first choice. Wireless certainly provides an opportunity to augment those fiber build outs, help get at least some basic services out to very rural areas that may otherwise be too costly. PON's generally going to be the lowest cost solution for the reasons we mentioned earlier on. I mentioned the business plan. We kind of like the open access, but always look for opportunities and new ways to generate revenue through offering business class services, especially if you can offer service level if you can provide service level agreements and meet strict mean time to repair and service up times. Those types of services demand higher cost to the customer. So you can definitely generate more revenue from those. I mentioned, we talked about the outside plant. I can't emphasize it more. Make sure that when you go in, what your end solution is going to be, and then design that fiber network to match that end solution. And there's not a one size fits all. And that's, I think, one thing that we wanted to get across here. There's not one solution that's going to fit every scenario. Oftentimes, we're going to look at a combination of fiber and wireless. As Scott mentioned, maybe do some microwave backhaul and some other things. So there's a lot of different options as we, as we look at these different areas, and whether there's a lot of trees, whether it's flat, just so many different things to consider with geography and population density. So all of that will help drive the technology solutions that would be implemented. So Claire, I ran through that pretty fast, so I know we're running out of time. I think we're off to the last slide of questions. Any other questions?
And it is 3:59. We do have a couple great questions that I want to get to in case people need to drop off, because it is 3:59. I want to say thank you so much for attending, and we hope we'll see you on December 16th. But please, if you have a minute, stick around. Drew Hansen has a couple wonderful questions. All right, so the first question is for John. John, why wouldn't a municipality just run the ISP itself versus selling wholesale to others like Anacortes? It's not that hard, is it? It's a great question.
How hard can it be, right? that is a good question. Let me stop the share. And the reason a lot of entities don't do that, and even the PUDs that only had the option of doing wholesale up until this year, where they can finally do retail, say that they don't want to move into the retail space simply because of the increase in responsibilities that you have to take on as a retail provider of services. Right now, they provide the infrastructure, and then the service provider really deals with the end user. When the end user can't get to a website, people are having problems with speed test, or they can't get their computer working. All of these problems are handled by the service provider. All the marketing is handled by the service provider. All of the all the support, technical support, is handled by the service provider, and relate, and sometimes have to call the PUD. So you can either, if you want to do retail, you have to staff up for that. Whereas if you do wholesale, you can put a lot of those responsibilities off on a partner, a service provider partner. Now, there's nothing wrong with doing it yourself, right? If that's the business model that a municipality would like to take, or even a PUD would like to take, you can certainly do it. You just have to understand that you have to basically build a support team that's going to be able to handle all these additional calls. You got to build a marketing team. Typically, if you're not in a competitive industry, you don't already have marketing staff on board. So there's a lot more responsibilities that come along with a retail service offering versus wholesale. But your margin, you're not splitting your margins with. So you have to look at what the additional cost is to bring on those resources, and how much it would cost you to hand those off to a service provider in your split revenue, and decide which one makes the most sense. But both can work, and it really just depends on what the appetite for taking on those new services are for that entity.
That's a great question, great answer. Thank you so much. And then he also has a question for you, Scott. I've heard of community-owned mesh networks, like in Detroit. Do you know anything about these? Are these basically fixed wireless access points, as you described?
Yeah, so what I know is that every wireless network that I've seen that came out of a city that was unlicensed spectrum was typically problematic. And I mean, I can point to the city of Portland. You could probably, the long list of cities that have tried installing something only to rip it out or to just have it go away. That's a long list. And really the problem is it's a lot more, as I mentioned, wireless technology. There's a lot of voodoo and black magic that goes into it. Really, it's just RF engineering, but there's so much that it's affected by. And typically what that means is you need a lot more access points than you thought you did originally. And what that means is that's a lot more money than you thought you needed to spend originally. And so, you know, to design a network and see the experience and then go in and correct where you've got holes, you know, it's a process and it's expensive. And I think what we're seeing, some of those can be, you know, some of them can be successful, but, you know, I think what we're seeing is as time marches on, the likelihood of those becoming more and more, you know, usable is increasing. But I think a lot of the early pioneers suffered a lot of failures because, you know, of just the finicky nature of wireless and specifically unlicensed wireless. So
Thanks, Scott.
Yeah, that was really helpful. Okay, thank you all so much. Most of you stuck around, so I hope you have a wonderful evening, and I hope that we will see you again on December 16th for the second half of our workshop, where we will sort of take it the next step of business models, funding the network, and operation solutions, and kind of close out this conversation. So thank you so much, John and Scott. That was really informative and interesting, and have a wonderful night, everyone.